Welcome to the Tech Egg. Don't get scrambled. Enjoy the video.
You begin by verifying hardware and drivers, know your GPU model and that it supports CUDA. Install the vendor driver, then the CUDA toolkit version that matches the libraries you will use. Once done, create a Python virtual environment so system packages stay clean, and pip install GPU-aware libraries such as cuPy or PyTorch with CUDA wheels. Make sure to match CUDA versions exactly. This prevents runtime mismatches and saves time when you move to testing and development. Next, you install the GPU-enabled Python stack and configure environment variables so the runtime finds CUDA and cuDNN libraries. Use the official package builds, for example pip or conda wheels targeted to your CUDA version, and then export path and LD library path on Linux or adjust system path on Windows. Once installed, open Python and run a simple tensor or array that requests the device. Confirming a GPU device proves the pipeline works and lets you iterate on code with confidence. Finally, execute your Python program explicitly targeting the GPU and monitor usage with tools like NVIDIA SMI so you can see memory and compute utilization. Once running, profile to find bottlenecks, tune batch sizes, and use library-specific best practices. For instance, pinned memory or fused kernels to improve throughput. If things go wrong, reboot the driver, confirm CUDA, cuDNN, and package versions align, and ensure you activated the correct virtual environment. This one troubleshooting step resolves most failures.
Thanks for watching. Consider subscribing if I helped unscramble your problems.